give a small demo for our real-time embedded systems course project. So the project which we implemented is a traffic sign detection system, which is going to be real-time. So my name is Harish, this is Ram Narayan, and this is Karthikeyan Mani, and we are going to take a car and test our system outside. So we simulated an environment where we can test the system. So we're going to scroll through the training images on the monitor, and over here we've set up all the laptops, and this is going to be the Jetson Tegra K1, which is going to be the platform of our choice. So all the LEDs, each of these LEDs represent a certain sign. So as you can see, we have crossing, we have a speed limit, we have a route, and we have a stop sign. So the basic implementation is going to be demonstrated by Ram.
Right. So this is the system, and now you can see we have a pentagonal sign, which is basically the crossing sign. And as we can see on the system, there's a simple GUI screen that shows the different schemes of representation. Right, so basically we're using a few algorithms to implement a very robust orientation invariant system, and for that we're going to use the surf algorithm, before which we're going to run a canny detection to find the different contours. As you can see, the black and white binarized image is basically the contours. In this image there are 2 points of interest, regions of interest, and they are the sign itself and another random rectangle that appears. So this is the sign of interest, and this is got through the canny contour detection system. The next step is the feature detection algorithm, which is the surf, which essentially detects key features in an image, matches it, and looks at the different rotations and variations, matches it, and the green box is essentially the region that it's localized the road sign.
So yeah, as Ram explained, there are basically 3 services in the real-time system that we have developed. The first service is the camera capture service that is running over here, and the second service is the canny edge detection service, which gives the extracted image to the surf service that is running over here. Surf is the main algorithm of our system, and so it is given the highest priority, and it is running at 3 Hz. The camera capture service is of the lowest priority, and we have kept it as 2 Hz, so it's basically like 2 frames per second. So what I'm going to do is, Ram explained the system in the laptop. We have implemented the whole system on the Tegra TK1 board, and I'm going to run it on the board using Ethernet connection. I'm taking the camera off the laptop and connecting it to the board.
Just another note, as you can see, the trained image in this case is the pedestrian symbol, and the other image is stop sign, and as you can see, very few key points have been extracted and matched, hence it's not a match.
So as you can see, the algorithm is being run here, and the time taken by the surf is about 130 to 150 milliseconds. As you can see, it's running over here, and the detected object is object 0, which is the stop sign in our case, and the LED for the stop sign is glowing, and the other 3 LEDs are turned off. Now what we are going to do is, we are going to scroll down the TV, and we are going to detect other images. As you can see, the TV is showing the speed limit 35 image, and the LED for speed 35 is glowing, and the other 3 LEDs are turned off. Now we are moving to the next image, which is the pedestrian image. As you can see, the pedestrian crossing LED is glowing, and the other 3 LEDs are turned off. Now what I'm going to do is, I'm going to simulate the real-time environment, and I'm going to move this camera back and forth. And as you can see, the crossing LED is still glowing, and the other 3 LEDs are turned off. And we are going to show a image that is not in our training set, which is the last image, which is the two-way image, and all the 4 LEDs are turned off. So that's it for the demo that we have. Thank you for listening.